Friends, welcome to Akul Live. New groundbreaking research has completely redefined how fast our solar system is truly moving through cosmos. For decades, the standard model of cosmology has used a certain velocity estimate, but a new study suggests our speed is three times higher than they previously thought. What are its implications? Let's discuss this further. You know the feeling. You're driving maybe a little fast, and suddenly the flashing lights appear in your review mirror, and you just get a speeding ticket. Imagine the entire solar system just got pulled over by the cosmos because, according to the staggering new research, every single one of us, you, me, Earth, Mars, Jupiter, we are all collectively racing through space three times faster than scientists ever believed. That is not a typo. Our velocity through universe is fundamentally shockingly incorrect in textbook. This isn't just a minor correction. The challenges this challenges very fabric of the standard model of the cosmology. Today, we are going deep into the science of speed, relativity, and how one radical new measurement could force us to completely rethink our place in the universe. Get ready because we have officially put the pedal to the cosmic metal. To understand why this new discovery is so dramatic, we first need to understand what we thought our speed was, and more importantly, what we were measuring it against. For decades, our cosmic speed limit sign have been cosmic microwave background or CMB. Think of CMB as a faint uniform afterglow of the Big Bang, a cosmic residue speed evenly spread evenly throughout the space. If you want to know how fast you are moving through universe, you measure your speed relative to this still background. We have established that the entire solar system is moving towards a specific region in space, a phenomena called the CMB dipole. For years, the accepted velocity of our solar system relative to the CMB was about 370 kilometers per second. That is over 820,000 miles per hour. Already fast, right? So, this speed and how we measure it is a foundational piece of the standard model of cosmology. This model is the bedrock of how we understand the Big Bang, the expansion of the universe, dark energy, dark matter. If the speed is wrong, the entire model gets a tremor. But what if the lake isn't still? What if our measuring stick, the CMB, isn't the final authority on cosmic stillness? That's the question the new researchers asked, leading to a jaw dropping answer. Think of the galaxy clusters as massive gravitational bound cities of the stars spanning hundreds of millions of light years in distances. Scientists posted that perhaps a more accurate measure of the universe's true rest frame wasn't the CMB, but the average motion of these most massive structures. The researchers compiled data from thousands of these clusters, observing their light. If we are moving towards a cluster, its light appears blue shifted, and if you are moving away, it is red shifted. By averaging out the motion of all these clusters across the entire sky, they created a new independent cosmic reference frame. It's like establishing a stable grid against chaos of the cosmos. And that is when they got the speed reading that broke the internet. The speed of the solar system relative to this new galaxy cluster frame isn't 370 kilometers per second. It's closer to 1230 kilometers per second. That is three times faster than what the CMB was telling us. We are absolutely flying. To put that in perspective, that's over 2.7 million miles per hour. This doesn't mean the CMB measurement was wrong per se. It means CMB itself is not perfectly still. It suggests the entire cosmic neighborhood that contains our Milky Way is being dragged or has a bulk flow that is significantly faster than what we accounted for. It means our entire local group of galaxies is moving at a blistering pace relative to the rest of the universe's massive structure. We are not just a speedy system, we are part of a giant, speedy galactical caravan. And this is where the implications get truly mind bending. Because of the solar system is moving this fast, we have to ask why. This 3x speed difference creates what scientists call a profound tension in the standard model of cosmology. Why are two reference points, which is the CMB and the galaxy cluster, telling us such wildly different speeds? If the standard model is correct, these two measurements should statistically be much closer, but they are not. One possible answer is that there may be an enormous, previously unknown gravitational structure, perhaps a super cluster, or a massive concentration of dark matter pulling our entire local region of space towards it. This kind of bulk flow is sometimes referred to as a dark flow. It suggests there is a gravity source outside the visible universe, maybe even a region of space that existed before the Big Bang that is exerting influence. We are being pulled by an invisible, massive cosmic tractor beam. The other, more dramatic implication is that it means we might have to, fundamentally alter the standard model of cosmology itself. The lambda CMD model perfectly describes the universe on huge scale, but this speed discrepancy hints at a flaw. Perhaps our assumption about how matter, energy, and space-time interact are incomplete. Is it possible that the acceleration mechanism of the early universe or the distribution of the dark matter are less uniform than we thought? Does this mean our calculation for the density parameter omega needs serious adjustment? This is where the scientific process shines. One discovery, no matter how dramatic, needs independent verification. Other teams are now scrambling to replicate this measurement using different sets of data like radio galaxies or quasars. The next few years of cosmic observations will be absolutely critical. The solar system speeding ticket could either be a fluke of measurement or the first crack in the foundation of modern physics. Imagine that. Every moment you sit here, you're moving at over 2.7 million miles per hour through the cosmic ether, pulled by a force we can't yet fully see or understand. This revelation brings an exciting kind of chaos to the world of cosmology. When measurements don't line up with theory, it means something amazing is about to happen. It means our knowledge is about to expand. The bravery of these researchers to challenge the decade-old foundational understanding of the universe is what science is all about. You don't just accept the data, you question the reference frame. This finding reminds us that the universe is far more dynamic and far more mysterious than our models often suggest. We are not stationary observers. We are dynamic participants in a high-speed cosmic dance. So friends, what do you think is pulling us? Is it a dark flow or the standard model of cosmology is incomplete? Let me know your thoughts in the comments below. I read every single one and I love seeing your hypothesis. If this video blows your mind and made you look at the sky a little differently tonight, please hit that button, that like button. It really helps the channel. And for more groundbreaking discoveries, incredible physics explainers, and the latest news from the edge of the universe, make sure you subscribe and ring that notification bell. And I say goodbye, only to catch you again very soon in the next one.